All right. So, for Video Explainer 2, I chose the problem where he's catching the ball on the ice. Yes, and so our situation is Olaf is standing on a sheet of ice that covers the football stadium parking lot in Buffalo, New York, and there's no friction really, or very little, because it's ice. Maybe he's wearing some very slippery shoes or something. And so his friend throws Olaf a ball of mass 0.4 kilograms that's traveling at 12 meters per second. And then we're given that Olaf's mass is 69.8 kilograms. All right. So I guess our plan here is to draw the situation, slash aka the system, for both part A and part B. This is of course important because part B is very different in that it is an elastic collision rather than inelastic, which makes things a little more complex, but nonetheless not so bad because one is already at rest, so that makes things a little bit simpler. All right, so then we're going to outline our known quantities and find the momentum, total momentum in the system, which is especially important for part A. And since one's at rest and it's an inelastic collision, the momentum that one has is the same momentum that it'll have at the end. We just have to do a little math, dividing things to figure out velocities and that sort of thing. So that's part A, is finding the final velocity if the collision is inelastic. Sorry, I wrote elastic on the slide, but it's inelastic. And for part B, do the same, but use the impulse, so the change in momentum, and conservation of momentum to find the final velocity of Olaf in the elastic collision. All right, so here's my diagrams. On the left, as you can see, that's part A, so it's the elastic collision where the ball collides with him, he catches it, and so they move off in the same direction with a new speed, which is, well, new velocity. And then part B is different. The ball bounces off at negative 7.5 meters per second. That must have hurt because that's pretty high velocity. And so yeah, Olaf also moves away in the other direction. And so there's an impulse. Part A, find VF assuming Olaf catches the ball. So we know all the masses and the velocity. And so all we're doing here is plugging into the momentum equation and simply solving for the momentum in the ball, because that's the only momentum in the system. We get 4.8 newton seconds due to conservation of momentum. We just sort of plug that back in, but this time there's the same momentum, just the mass is the combined mass of the football and Olaf. So it's 4.8 newton seconds divided by 70.2 kilograms. And so that gets us 0.0684 meters per second. So not surprisingly, this small mass only causes just a tiny bit of velocity when it's caught. Just pushes him ever so slightly. So now for part B, which is a little different, the collision is elastic. What's the final velocity of Olaf after the ball bounces off at negative 7.5 meters per second? So we find the initial velocity, which we did before, still the same, 4.8 newtons per second. The masses and the velocities initially are still the same, so the momentum is the same. He still starts at rest, which makes this pretty easy, relatively easy for us. And so the momentum final of the ball, we know the final velocity, so we just do that again, same thing as before. The 0.4 kilogram ball times the final velocity, negative 7.5 meters per second, and we get final momentum of the ball of negative 3 newton seconds. Using this, we can find the impulse, or the change in momentum, and what we get is negative 7.8 newton seconds. And so the impulse will be the same on the, will be like the opposite, well, equal and kind of opposite of the impulse on the ball. And so the final momentum of Olaf, because he started with 0, is just plus 7.8 newton seconds. And so now, to find Olaf's velocity, we just plug in the mass of Olaf, which is 69.8 kilograms. And when we do that, we get 0.112 meters per second. This makes sense. He was pushed in the opposite direction that the ball ends up going, because the ball bounces off. And again, very low velocity, but more than the inelastic collision, which is because it's bouncing off, and so there's greater impulse. Thank you. That's my video.